All right, so for this one, I actually solved this 5 Caillou challenge, which is usually out of my comfort zone, but I was able to solve it for this one. So basically what we're doing here is we are given a number, so whatever the number could be, it could be 4,895, 5,895, whatever it is. And we are basically trying to find if there are two Fibonacci numbers, two numbers in a Fibonacci sequence that multiplied together equal that number, and if so, return true. So we're going to be given a number, and what we're going to return is an array, an array of three things: the two numbers that would be multiplied together to equal that, and if it's true that those two equal that number. If it's not true, we will return the two numbers that are the two Fibonacci numbers that are one greater than that number multiplied together. So for instance, here we have 714, and because Fibonacci sequence 8 and Fibonacci sequence 9 multiplied together equal 714, that's true. So it'd be those two numbers, which is 21 and 34, and true. So that would be true. But for this number 800, because 800, there isn't two Fibonacci numbers that are multiplied together that equal 800. We will do 34 and 55, because 34 and 55 are the two Fibonacci numbers that produce a value that is greater than that is the one after 800, because the Fibonacci number is before that. So 21 and 34 produce something lower, 714. So the two numbers below produce 714. The two numbers higher produce whatever they produce, which is let's see, 34 and 55. They produce 1,870. So you take the over. You take the number that is over. So to solve this, we have the number that gets put into this, which will be whatever they give you. And then what we're gonna do is we're gonna create a Fibonacci sequence manually here. So we did it all the way up to Fibonacci sequence 74. So basically, the Fibonacci sequence is Fibonacci 0 is equal to 0. Fibonacci 1 is 1. Fibonacci 2 is 1 plus 0. Fibonacci 3 is Fibonacci 1 plus Fibonacci 2. Fibonacci 4 is Fibonacci 2 plus Fibonacci 3. Fibonacci 5 is Fibonacci 3 plus Fibonacci 4. You get the idea. So it's the number equals the two last numbers. So Fibonacci 3 is equal to 1 and 2. Fibonacci 4 is equal to 2 and 3. Fibonacci 8 is equal to 6 and 7. Fibonacci 9 is equal to Fibonacci 7 plus 8. So you can write it out manually. You can write it out exactly as it is, or you can actually write it out like this, like let Fibonacci 19 equal Fibonacci 17 plus Fibonacci 18, because we already defined it. So that's what we did. We made a bunch of those for any case all the way up to 15 places. And then what we do is we create a bunch of if statements, and the if statements are going to check first if it's true. So if that value they give you is identical to any of the Fibonacci numbers multiplied by each other, so any of the consecutive Fibonacci numbers multiplied by each other, we would do those two. We would return those two numbers, those two Fibonacci numbers plus true. So for instance, let's say we just plugged in 4,895, which the result is 55 and 89. It would be 55 and 89 are, let's see here. 55 and 89 are sequence F10 and F11. So if we go down here to F10 and F11, we do if the production is equal to F10 times F11, return 55 and 89, the two numbers, and then true. But let's say that it was a number that, for instance, the next one is greater than, so it's 5,895, but there isn't two Fibonacci numbers multiplied together that exactly equal that. So we check for those cases in the in our false statements. So we have a bunch of if statements that check for false. So these ones would check if the number is, for instance, this one is greater, it's if the number is less than the Fibonacci 11 and 12 and greater than the Fibonacci 10 and 11, we go with let's see here, 89 times 44. 89 times 144. So if so it basically if it's greater than 10 and 11, Fibonacci sequence 10 and 11, and less than Fibonacci 11 and 12, we go with the lower lower amount, and we say false because it's not equal to those two identical numbers. This is a very hard question. If you have any questions about this, you can put in the comments. But basically, it's called the product of consecutive numbers, and it's a 5 Caillou challenge. Yeah, so this can be a pretty challenging one, but you work through it by just creating cases for any possible case all the way up to as many digits as you want. And since it's a Fibonacci number, it grows exponentially. So yeah, that's kind of how you do that. I created cases all the way for 74 Fibonacci numbers for both false and true. And when you test it, it works. And when you submit it, it works. So yeah, that's how you do that. And sweet, I got 500 plus honor, so I have a new ability to moderate comments marked as having spoilers. That's great. So yeah, if you have any questions, any more questions, let me know. Thanks for